All right, this video is going to be looking a little bit deeper into inverses. We've looked at them algebraically, so now we want to see graphs and tables of inverses. All right, so first we're going to kind of review what we learned already about algebraically, and that will kind of help us get a little introduction to the graphs and the tables. So if you recall, let's say that this is our original equation, and we look through all the transformations that we can see and what these operations mean. Then if I start off with the x, the first thing that's happening to the x value is you're subtracting 1. After you've subtracted 1 from the x value, you're taking whatever that value is and you're cubing it. After that number has been cubed, it's going to be multiplied by 2. And then after it's been multiplied by 2, you're going to add 4. All right, so that means that for the inverse, if we're going to undo each of those operations in reverse order to get us back to the original number, then the first thing we would do is subtract 4. Then we would divide by 2. Then we would cube root. And then last, we would add 1. All right, so if I go through and use this to write out my inverse would start off with x, and we would be subtracting 4 from it. The next step says divide that answer by 2, so this answer divided by 2. The next step would be to cube root what you get for this. So cube root of x minus 4 divided by 2. And then the last step is to add 1 on the end. So y inverse equals the cube root of x minus 4 divided by 2 with a plus 1 on the end. All right, so let's think about what would happen if we were to plug some numbers in. So for the original problem, I'm going to start off with an x value of 2. So if I do the first operation, I subtract 1. 2 subtract 1 is 1. If I then cube this answer, 1 times 1 times 1, still 1. Multiply that answer by 2, and I get 2. Add 4, and I get 6. And so that means that this is my y value. So the original problem had an x and a y coordinate of 2, 6. All right, now if I do the same thing with the inverse, when we do the inverse, we say we're going to switch it. We're going to take our end result, and it's going to get us back to the original. So I'm going to take my end result. X is going to equal 6 this time. So I'm going to take my x value and subtract 4. That gives me 2. Then I'm going to take that answer and divide it by 2. That gives me 1. Then I'm going to take the number and I'm going to cube root it. So I have to see what number multiplied by itself 3 times equals 1. And that's just 1. And then I'm going to add 1 to it, and I get 2. And this is the output, so this is the y value. So if the original equation gave me the 0.26, then the inverse equation is going to give me the 0.62. So when you're working with points on a graph or numbers in a table, they're very easy to find the inverse of. You just switch the x and the y. That's all you have to do. It's that easy. Switch the x and the y. All right, so we're going to go ahead and look a little bit more deeply at this problem that we have. I'm going to go ahead and rewrite it so I don't have to keep shifting my paper up and down. So if we were looking at this cubic function and we wanted to graph it, we'd have to do our little chart to see what each of the points are once we do the transformations. So the first transformation I can see is that I need to stretch the graph by 2, and that's going to stretch the y coordinate. So -2, -16. Just taking all of the y coordinates and multiplying them by 2. And then the next transformation is to shift to the right. So I'm going to add 1 to all of the x coordinates. And the last transformation, is to move up 4. So I'm going to take the y coordinate and add 4 to each of those. Alright, so this right here is the original function. So if I have my inverse, that was the third root, x minus 4 over 2 plus 1. We don't even have to stress about what these transformations are. We can just take those points and we can switch them. All right, I'm going to put a little grid on here so you guys can see what I'm drawing accurately. On your notes, it's okay if your graphs aren't perfect. I just figured it'd be easier for you to follow along if my graph looks better. So if I go ahead and graph these points, my first point was -1, -12. Then I had 0, 2, 1, 4. 2, 6, and then 3, 20 is too big. It's off my graph. So I can at least draw this part. And then if I graph the reverse order of those points to get the inverse, I've got -12, -1, 2, 0, 4, 1, 6, 2, and then 23 is off the graph. Drawing's not perfect. Okay. Now, if you can see, when we look at those graphs, it looks like if you were to fold the paper in half right down here, that is like the axis of symmetry for these. You can kind of see that they're reflected over this line right here. And if you guys check to see what that line is, if we write the equation of the line in y equals mx plus b form, we would say that's y equals, the slope is up 1 over 1, so it's 1x. And the y-intercept is 0, so we'd say 1x plus 0. So this line that I just drew right here is y equals x. And we're going to say the inverses are reflected over the line y equals x. Which kind of makes sense because if you're thinking about it, you're switching the x and the y coordinates. So that's what your graphs should look like. Now, another interesting part that you might notice is if you look at the original graph has a y-intercept of 0, 2. The inverse has an x-intercept of 2, 0. Again, this makes sense because the x and the y coordinates are changing. So something that was a y-intercept on the original should be an x-intercept on the inverse. We're also going to go ahead and take a moment and find the x-intercept of the original because that's going to tell us the y-intercept of the inverse. All right, so there's our graph. And if I look for the x-intercept, I find that it's -0.260. And I'll go ahead and show you guys how when I plug the other one in, how the y-intercept ends up being that same point. So we've got x minus 4 over 2 and if I plug in 0 I get the same point. All right, next we're going to go ahead and find the inverse of a graph. And again, I'm going to draw it on here just so you guys can see the points really clearly, but you can draw it on your regular notebook paper. So if the original graph, I'm just going to put some points on here. I'm going to put the point -5, +2. +3, +2, and then this will be the point -5, -1, and then +3, -1. So there is our original. And I'm going to write a few things about the original. So I have those 4 points. And then I'm also going to write down what the domain is for the original and what the range is. So the domain describes, as you guys know, the x values that are used in the problem. So I can see an x value of -5 is used, -4, -3, -2, -1, 0, 1, 2, and 3. Those are the x values that I can see being represented. So I'm going to say the domain is from -5 to 3. The range, I can see y values as low as -1 and as high as 2. So the range is from -1 to 2. All right, so now I'm going to go ahead and find the inverse of this picture. So I'm going to take all those points and flip them. Let's change this, the x and the y coordinate. So 2, -5, 2, 3, -1, 3, -1, -5. I'll go ahead and graph this in a different color. So now if you look at those two rectangles, first of all, we can see if we were to draw in the line y = x, just like before, that these are reflected over that line. And then if you also would compare, you might see that the domain now for the red one, for this inverse, is from -1 to 2. So if the range up here had to do with the y values, then those same numbers would now describe the x values. And the numbers up here that described the x values are going to describe the y values in the inverse.